Good morning, USGBC LA. My name is Tony Lee. On behalf of Southern California Edison's Energy Education Center, Irwindale, I'd like to welcome you to the Energy Center. Today we will be going over a variety of different exhibits that our facility offers. In addition to our facility, we will also talk about the different offerings provided by our curriculum, what we offer here to customers, and the different types of activities customers can engage in. But before we get started today, I hope you are all hands-free and you are all practicing CDC guidelines and social distancing. So let's get started. The first exhibit we'll be touring today is called the Smart Energy Experience. This exhibit was built in 2010. It was built as part of the smart meter deployment. We wanted to build a platform to help customers understand the deployment of the meters and if they have any questions for us. However, since then, the exhibit has gone through several various different projects to help customers understand the different technologies around new construction or retrofitting a home. To help further expand that conversation, I'm going to invite Kavita Rodriguez, who's going to give us a tour of the exhibit and talk about the different things we have done in the home.
My name is Kavita Rodriguez and I work in residential new construction where we offer programs for energy efficient new construction. This is the Smart Energy Experience where we have tried to showcase a home that is all electric, energy saving, energy efficient. When you talk about all electric homes and energy saving homes and energy efficient homes, people normally focus on the renewable energy and all the cool technology, but really when you're building a home that is trying to be as efficient and zero everything, you really need to start with the envelope, and that's what this part of the exhibit does. We talk about the construction of the building envelope. We focus on framing, insulation, and air sealing, which are the really important parts of construction. So this first module in this display shows various advanced framing techniques. We start with 2x6 construction, which is 24 inches on center, and show features like an insulated header which reduces heat transfer through the wall, different ways of building out a corner to reduce lumber such as the 3-stud corner. Another advanced framing technique that is less common is using staggered stud, as you see in the back. We also look at the intersections of interior walls with exterior walls, where you usually have a number of extra studs which create an unnecessary thermal bridge. There are methods of construction that reduce this bridge. One way is by ladder framing, which we show here. Module 2 showcases structurally insulated panels. So let's talk about framing factors. Framing factor is basically the percentage of lumber in a wall when compared to the insulation in that wall. To put it into perspective, a normal construction 2x4 stud wall with 16 inches on center has a framing factor of about 25%. An advanced framing wall, such as the 2x6 wall with its studs at 24 inches on center, can go down to about 17%. This structurally insulated panel wall has a framing factor of 9%, which tells you exactly how much insulation there is in this wall. Of course, the less lumber and the fewer studs you have in a wall, the better insulated the wall will be. This particular structurally insulated panel is insulated with EPS that has been impregnated with graphite to give it a little extra insulating factor. These panels are prefabricated, generally off-site, brought on site. They are pre-drilled for plumbing and electrical wiring. This one has a standing seam metal roof. Okay, so this module demonstrates open cell spray foam insulation. So this module has insulated slate tiles I also want to point out that most of these modules we have show a raised heel truss, which is important to be able to insulate right up to the edge of the roof framing. It also allows you to lay insulation flat without any compression, so you get the full value of insulation right at the edge of the home. We also showing in this one U stucco, which is an insulating stucco, which is this stucco is about 7/8 inch thick and has a value of R2, so which is a lot higher than regular stucco. It's really good if you want to retrofit a home and you're only replacing stucco. You can add some external insulation. It's also fire resistant, so it helps with resiliency. So with module number 4, we are demonstrating an engineered I-beam rafter instead of the trusses. This one is also shows you what ducts and conditioned space condition would look like. We've got fiberglass bats on the ceiling, as well as bat insulation under the roof deck. So this would be where you have all your ductwork and your your equipment in a conditioned space. So this wall has expanded polystyrene exterior rigid insulation. It gives it a value of about R6. And one of the interesting details we have here is an insulated window buck. So when you have external insulation, rigid insulation, one of the things that you have to think about is how your window frame gets mounted on the wall in order to keep the surface flat for waterproofing and for air sealing, and as well as the exterior finish. So a very common method is to use a window buck, and conventional window bucks are made of wood, and these wood can compress and wood can also absorb water. So this is an insulated window buck, so it helps make sure that the insulation goes all the way around the window frame, and it really reduces the thermal bridging effect of a window. So in these wall sections, we try to show as many different materials as possible in as many different combinations as possible, just to demonstrate how you can get to the new 2019 energy code. So all these wall sections actually exceed the Title 24 prescriptive requirements for insulation. With this module, we really try to show what you would need to do if you were using conventional construction of 2x4 framing 16 inches on center, and the kind of insulation you'd have to use to get up to code. We use closed cell spray foam both in the attic and in the walls. So the attic insulation is R38. The wall insulation with basically 3.5 inches of closed cell spray foam, which gives you an R23 point something. We had to use external exterior rigid insulation, and we used a product called Kingspan, which gives you an R8 per inch. So this is 1 inch of Kingspan. As you can see, we have a conventional window buck here, and we have the entire assembly U value. We achieved a 0.038. So this would be a very expensive way to reach the prescriptive code requirement, but it can be done. In module 6, we reached a U factor of 0.042. We have blown-in cellulose in the attic, and we have mineral wool bat insulation in the walls. Now, mineral wool is a better insulator than fiberglass bat. It's easier to install because it's slightly more rigid. It's more sustainable. It has a higher recycled content, and it also is a really effective insulation in fire-prone areas because it is fire resistant. It's not fireproof, and it also doesn't absorb water, so it would dry out really easily. Here we also have used exterior mineral wool, which gives you an R4 per inch, which is pretty standard. But we've also used something called Tyvek Thermarap, which adds an R2 to the exterior of the envelope. Here we're also demonstrating how important it is to seal penetrations. So we have all the plumbing and electrical penetrations that have been sealed. And if you look on the other side, we also show, so this is an electrical box, and one of the things that people neglect to seal are the little holes inside the electrical box. So we have this open there so that you can look at the sealing that goes on inside there. This is a section which has blown-in fiberglass insulation at the attic, which is pretty conventional, but it uses cementitious foam as insulation in the wall. This particular foam is called Aircrete, but it's a blown-in cementitious foam, which is also very useful if you're doing a retrofit, because in a retrofit situation, you often have other like old insulation and things that you don't really know what exactly they are in your wall. And so cementitious foam fills in all the gaps, but it doesn't expand. So you don't have any issues with drywall being pushed out or cracking and things like that on your stucco. It just fills in all the gaps and then hardens. It's also fire resistant, so it is. That's also a very useful property. We've also have this particular module shows extruded polystyrene rigid foam insulation for an R5 per inch. We have the standard wood buck. We also show insulated tiles on a few of these modules. This particular module has an above deck insulation. It's called Wedget, and it fills up the space under the tile. So up here we have fiberglass pad in the attic, but we have blown in fiberglass with netting in the walls. We have polyiso rigid foam on the exterior wall, and I think that's about it for this one. The other part of this display, which really shows how the insulation works, is here. This is where we show how effective these three types of insulation are when it comes to thermal transfer and also sound transfer. So we're comparing spray foam insulation with cellulose and fiberglass. So what we have here, this setup has a fan which is pressurizing the lower box, and it's also heating this interior space here. And right now the temperature of this space is 110 degrees. And you can see we have the temperatures of the spaces beyond the insulation. So for fiberglass insulation, that temperature is 95 degrees on the other side of the fiberglass. This is not a condition that it would be in the attic because there are other factors in an attic. This is just heat transfer through this particular insulation. You also see that this little ball on top here is extremely wobbly because that is the air that's blowing through, managing to get through this insulation. Whereas we have the cellulose insulation where the temperature beyond that is just 81 degrees, and even though the ball is up at the top here, it's not really moving very much. So there is air being transferred through, but it's not as much as the fiberglass. And you can see in the spray foam insulation, the temperature is only 71 degrees beyond there, and that ball is right down there at the bottom of the tube. We also have here where we've set up a bell behind each of these three panels, and it's the same sound level, same decibels, and you can hear the bell through that insulation and through the cellulose and through this is open cell spray foam. If you had closed cell spray foam, it would be even better. And that's it for the walls display. This is an example of a triple pane high performance window system. So this particular window is a fully insulated double sealed fiberglass frame. There's a low E coating and it's got inert Krypton between the panels. It is triple pane, so it is a heavier window than a conventional window. But the U factor for this window is a 0.1. And to put that in perspective, right now Title 24 has a maximum U factor of 0.3. So this is a very well insulating window. It's actually an insulation value of about R10. It's also very well sealed, and as you can see, also the French door has really good sealing, so there's very little air infiltration around these windows. It's got a solar heat gain coefficient of 0.15, and the Title 24 prescriptive is about 0.32, so that gives you a little bit of a reference point for where this window is. We also demonstrate, we're trying to demonstrate here different types of window films. So what we have on the top there is a switchable electrochromic film, which you can, depending on the direction of the sun and which of your windows are facing, whichever direction, you can switch on and off to provide shading that's integrated into the window panel. We also have a photochromic film, and this one it's passive in the sense that it reacts to wherever the sunlight is falling on the window, and you don't have to switch it on and switch it off. But as you have sunlight hitting the panel, it should darken. It's kind of like those transitional lenses you have in glasses. So after you talk about the home envelope, the next thing that you want to do is make sure that your equipment in the home is as efficient as possible. This is an all-electric home, and so we have all-electric equipment, and we started with a heat pump system for air conditioning and heating.
This is the heat pump condenser for the HVAC system. Heat pumps transfer heat rather than generating heat, which is why they are so much more energy efficient than a conventional gas furnace. We've opened up the wall a little bit so you can see the plumbing that is needed to run the refrigerant lines.
So this particular unit has two, we've tried to demonstrate the different interior registers, and one of the most common registers that people think about when you think about a mini split heat pump system is the wall register, which kind of looks like that. But there have been significant advances to the look and the intrusiveness of these registers, and so you can get wall registers that are less obvious. They also now make ceiling cassettes. So this is the air conditioning ceiling cassette for this heat pump system.
And you can see the plumbing for the refrigerant lines has been run within the roof framing. This is also a great application for retrofits because you don't have to install any new ductwork, and you can just run your refrigerant lines to where you need them.
You can do that in the ceiling plenum. You can also do that in the floor plenum between 2 stories of a home. The other biggest piece of equipment that we think about when you think about the energy use of a home is water heating. It's actually a really large proportion of your energy bill comes from water heating. And in an all-electric home, one of the most efficient ways of water heating is to use a heat pump water heater. So this is a pretty standard heat pump water heater. It's about 60 gallons. It is bigger than a conventional storage water heater because you have the condensing unit on the top here. You do get different models, and some of them have a split system where you have the condensing unit on the outside of your home, and then you'd have the tank, water heating tank in here. One of the good things about this is it can stand in your garage, and because of the technology, basically heat pump technology is heat transfer technology, and so while it is heating your water, it's also removing heat from the air around it, so it has a slight cooling effect when it's sitting in your garage. Next thing we can show you are appliances. And again, because it's an all-electric home, one of the most important appliances that you're looking at are your cooking, so your kitchen appliances, and also washers and dryers. So we have a heat pump clothes dryer here, which is very efficient, uses very little energy, and also water-saving clothes washer. We have an induction stove, which Andre will go into more detail later when he talks about induction cooking. Okay, so after you've built your home with an energy efficient envelope, with your really insulated walls and windows and air sealed it all, and then you put in your equipment, which is as efficient as possible, the last thing you do is add on your solar panels which would be large enough to cover the load, which is now as reduced as possible. And then you would add battery storage in order to take advantage of that solar system, and also increase the resiliency of the home in case of a blackout. You have so this is a very commonly available battery. It's about 9 kilowatt, I believe. It's wall mounted, so it takes up very little space in your garage. It's hooked up to the inverter, and the inverter is hooked up to the solar panels, and basically it converts your DC to your AC current. One of the things you have to remember when you're hooking up a battery is that it's not going to cover all the loads in your home at any point. That would drain it pretty quickly. So when you wire in your battery, you do want to think about the key things that you would like to stay online if you do run out, if power does go down. So your battery backup will power a few key things in your home.
Hi, my name is Andre Saldivar, and I'll be talking about residential induction. We'll talk about the energy and non-energy benefits of induction technology. Some of the energy benefits is it's a cooler kitchen. You don't have the heat coming off the stove or the range. Here we have a feature with a 5-burner range along with an electric oven underneath. And I get into the safety part about it is I have the unit on. I have some hot water boiling with the teapot here that's on. You'll hear it go off in a little bit. But I also turned on this hob here. And so it is on, but it's looking for it to close that magnetic field. And when I put it on, it will activate and it'll start to heat up. So that's one of the very first safety features of induction is I can go walk away from the unit and it'll shut off after a few seconds or minutes. Some will beep, some will flash like this one's flashing, but it'll shut off. I don't have to worry about coming back and turning off the pilot, or did I leave it on? So I'll go ahead and put it back on right now and I'll activate it again. Same thing, I can turn all 4 on and leave them on, but until I complete that circuit, that magnetic field, it'll just sit there in idle mode and draw no energy except for the board. A lot of people ask about the special pan. One quick easy way is if you get any type of magnet, you can put it on back of your favorite pot or pan that you got at home right now, and if it sticks, it's going to work on an induction unit. So a quick tip is use any type of magnet, stick it to the bottom pot of the pan or pot or a teapot or anything like that, and cast iron and all that will work. The other thing about induction is it's very easy to clean. As you can see, it's a glass top, and they've been tested to certain many standards about breaking glass. So there's a whole study and certification they got to go through about dropping a metal ball onto the glass several times from so many inches above. So glass is very hard. It won't break. It's very easy to clean. I can wipe down right after I'm done serving or cooking or anything like that. It's going to be very cool to touch. That's another safety benefit about induction is as soon as I remove the unit or the pot or pan that I'm using from, it is going to be a little warm, but it will cool down very fast. Now, all the energy goes into the pot or pan. So the pot and pan is going to be very hot. So don't touch the pot and pan, but I can put it back on there. As I started the video, I've been going back and forth. So the unit's been on, off, on, off, on and off. Again, when there's no completed circuit, is not drawing any energy, and this unit will flash at me. As soon as I put it back on, it activates, completes the circuit, and starts to heat up instantaneously. That's the other thing, it's quick heat. It heats very fast. And so I can have it at different temperatures, different different temperatures or different power levels. Now induction is rated by power levels if you do buy a unit with power levels. This one has 0 through 10, it looks like, and it's so any of those numbers represent a percentage of the total wattage of that hob or burner. So if this burner is a 2000 watt burner and I'm at 5 or 50% of that 2000 watt would be 1000 watts. So I'd be at 5, at the level setting of 5, it'd be 1000 watts that I'm putting into this. This unit here looks like it's a same size unit. So you can get units that are rated all 2000 watts for their individual burners or hobs, or you can get units that are rated in different wattages, like 5000 watts, 3500 watts, 2000 watts, and a 1500 watts as well. And this one also has a warmer zone that you can turn on as well. So they're all all in watts and wattage. Power levels are a percentage of that wattage. So another educational piece about induction is if I have a 5000 watt and I have a 2000 watt, level 5 here is not going to be the same level as a 5 on the 2000 watts. So a 5 would be at 2500 watts on this hob, and then a 5 would be 1000 watts on this 2000 watts. So that's another education you got to be. So you might say, hey, I'm burning stuff or I'm heating up faster. Well, yeah, you're using a larger wattage hob versus the 2000 watt here. And so that's where you might have to adjust some of the levels or some of you guys' cooking there. To get familiar with the technology, Edison has a lending program. I showed you the magnet already to check your pots and pans, but we do also have a lending program here that you can borrow a 120 volt countertop unit with a pot and pan up to 14 days to get your hands familiar, get your feet wet with the technology. And later on, I'll be showing a unit when we move over to the Food Service Technology Center. But again, this is residential. You can buy them in drop-in ranges where you can just drop in the counter, the top, whether they come in 30 or 36, or you can buy a full suite like we're featuring right now with 4 burners, a warmer zone, and a full electric oven. Hi, it's Andre again, and now we are in the Food Service Technology Center, or the FTC. And I wanted to stay on induction technology, but highlight some of the commercial. And then what I mean by commercial is some of the back of the house appliances that induction is available now. And we'll start with the large stock pot burner, 5000 watts, 7500 watts. But obviously, as you can see, there's a stock pot option as well. Works same thing with being activated when the pot's on and being disactivated when it's off. Stock pot single and double burners are available on the market now. We'll move over to some other technology that exists in the market. We have a countertop induction wok right now that we're displaying, boiling in some water. These can be in drop-in style, or it can be countertop like this as well. And there's some larger woks out there in the market. Then we move to what we call our 4-burner, 4-range. So we highlighted a residential 4-burner. Now we're gonna highlight a commercial 4-burner or 4-hob range. We have a cast iron comal on there. We have another pot, and we're doing some sous vide here. And again, if you're checking for what type of cookware will work, again, we just stick our magnet, and if it sticks, it's gonna work on the induction technology. With induction, as you can see, this is considered a 4-hob, but I can put multiple pans, pots, different cast iron cookware on there, and put up to maybe 6 or 8 pieces of cookware on there versus the standard 4 over the individual hobs there. One last thing to close it off, again, where you do have the residential lending library as well with the induction. Here's the brochure, and here's one of the actual units that you can use up to 14 days by applying at our lending program. One of the other technologies I want to highlight was electric deck oven. This is a game changer out there. It can get to above 900 degrees, which means you can do 3 different styles of pizza if you have a 3-deck tier oven as the one that we're showing off here. It holds the individual temperature for each of the decks. So I have it at 932 here for such as a Neapolitan pizza, an 800 degree here for an artesian pizza, and in the third deck here at 650 for a kind of a New York style cheese pizza here. It's one of the first ovens or one of the first technologies that can get that high and compete with the gas or the solid fuel deck ovens that exist in the market. I talked about pizza, but it also can do bakery. So you can do it for croissants and cakes and bread loaves and things like that as well in this style of electric deck oven. As you can see, there are 3 different temperatures. They will all hold at that different temperature. And to be able to cook the different products or the different styles of pizza. One final piece I wanted to highlight was our electric charbroiler. Yes, they do exist for both countertop, floor size model, and even the residential, both inside and external. So if you're building a barbecue, a custom barbecue, and you wanted to drop in a charbroiler, they do come in electric. You'll still get the same stripes, whether you're taking chicken breast, steaks, burgers, you'll be able to get that branding or that stripes in there. They're very easy to clean. That's one of the very benefits of it. Cleaning benefits, they're very easy to clean. You basically lift up, take the pot out and dump it into the trash or wherever. The control has 2 zones. It can get to 450 degrees. Again, you'll be able to get the char marks as you would get off a solid fuel or a gas charbroiler as you would using an electric charbroiler. So they do exist. Again, both countertop, floor model, residential barbecues in the backyard, electric charbroilers do exist.
I would like to conclude this tour by saying thank you for watching this video. We hope to see you guys here in the near future. The various different exhibits presented by Kavita Rodriguez and Andres Saldivar really just tells a small story of the Energy Education Center. There is much more here at the center. We hope to see you guys take advantage of our classes, our offerings, and come visit us. Thank you.